what I'll probably do now is write this equation down. So y equals 0.635x plus 64.928. Okay, that's the equation that we got for our data. So we can use this to predict the heights of a 23-month-year-old and a 27-month-old baby, okay? So all you do is plug in 23, all you do is plug in 27, use your equation, and you get those two values. So I think you can all do this at this level. So I'm going to kind of tell you what those are. So 79.533 is the height that you get for a 23-month-old baby. And for a 27-month-year-old baby, we get 82.072. It's kind of weird. Why would they say 27 months? Yeah, like, why would they... Okay, after 12 months, why would they not just consider that a year old? It's kind of weird. No, they're not. They're a year and 6 months. Oh, that's your error. You don't have to worry about that. Okay, yeah, you don't have to worry about that. So next, let's sketch the scatter plot and then the residual plot, which is new. We didn't do that yesterday. So let's go to the scatter plot. So we go to second, y equals, go to number 1, turn it on. Should be on for y'all because first period, or second period, I'm sorry, we kind of went through this. Just make sure it shows L1 and L2. Before you hit enter, or before you hit graph, I'm sorry, make sure that you go to zoom, zoom stat, or zoom fit, okay? So choose, let me try to get this right. I think it's zoom fit 0. Okay, so zoom fit. Maybe it wasn't zoom fit. Let's go to zoom stat, I think. Yeah, zoom stat. That's what it is. So what? Yeah, so you're here, right? You're in this screen? What's that? What? Yeah, you want to turn one scatter plot on. Just choose the first one. Make sure it's on. Make sure it shows L1 and L2 because that's what you put your numbers into. Before you hit graph, because if you just hit graph, your windows are not going to be set, so you're not going to be able to see the scatter plot. So for that work to be done for you, go to zoom, and you choose zoom stat. So you choose option 9. And it adjusts the windows for you so you can see your scatter plot and the line that goes through it. So that's what you're going to sketch for letter A. Okay, that's the sketch of the scatter plot. We were having issues with that yesterday because we couldn't get the line. So this would be the age. This is the height. Okay, and then, I mean, just try your best, kind of how it looks. Kind of, it's a positive correlation. So whatever, something like this. You have the linear regression going through it. Okay, so not too difficult. Kind of what you see there. Okay, what's new that we didn't do yesterday is we didn't sketch the residual plot. We just talked about what it was and how to figure it out. So I'm going to show you how to do that with this, okay? So go back to your scatter plot screen. So go back to second, y equals. Go back to here, option 1. So instead of L2, we're going to plot the residual amounts. So basically how far off we are for each set of data that we entered. So L1 you can keep the same. L2 we're going to change this, okay? So the way you change this is you go to second list. So second stat. Okay, and y'all should have a number 7 that says resid. Okay. So that's one you're going to choose. Then you didn't store your equation into y1. Right, you didn't? Oh, okay. Okay, when you do that, when you store, it'll do it for you. Okay. So you hit enter. So what you're graphing is you're graphing L1, okay, and you're graphing the resid. So before you graph it, again, go back to zoom, zoom stat. That way you don't have to adjust it. it graphs it for you. Okay. So what this does, it just displays a different display that shows you how far off it is from the actual values that that we're doing. In this case, the heights of the children. So this is what you're going to sketch for B, where it says to sketch the residual plot. So okay, you have like your horizontal line. This is the predicted amount. Okay, this was the residuals. Okay, just label them the axis, and then you just kind of plot what you see there on your screen. Okay, it's a different variation that allows you to see how close is your data to the actual predicted values. Okay, and that horizontal line that you see, that's the true values. Okay, those dots that you see around this, that's how far off your data was from using your prediction. So that's your residual plot. So for letter D, we'll skip that. We'll come back to letter D, finding the standard deviation. It's very easy to do. So E, let's interpret the y-intercept of our equation. So, okay, it doesn't tell us to write down what it is. It just wants us to explain this in terms of the context of the problem. So I would say it's the amount of height, okay, that you begin with at what? So at age 0. That's what a y-intercept is. Like, what is your y value when x is 0? So in terms of this problem, it's the height that you are, or that you begin with at age 0, basically when you're born. So that's your y-intercept. Okay, letter F, interpret the correlation coefficient. So what letter was that? Is that R or R squared? So it's R, okay. So R is 0.994. So yesterday I told you, you categorize this by 3 different ways. So if R is, well, I forgot what it was. If it's bigger than 0.75, let's see, I think it's, if it's bigger than 0.75, then you have a strong linear correlation. If it's between 0.40 and 0.75, there's a moderate. And then less than 0.40, it's a weak. Okay, so we would say, because our R is 0.994, that's almost equal to 1. Okay, it's pretty much saying our data is almost exact, our predicted values. So you would say there is a strong linear, whatever you want, relationship, okay, between age and height. Okay, and that's all you have to say. Just whatever R is, categorize it. Say if it's strong, if it's moderate, if it's weak. You just state that in for letter F. And then for G, interpret the coefficient of determination. So that's R squared. Okay, and that's, we always express that as a percent, and it's always in terms of Y in regards to X. So the way you would word that is, you would say 98.9% of the variation in the height, okay, so in the height can be explained by the change in age. Okay, in age. Okay, it's always Y in terms of X. So whatever percent your variations, 98.9% of the variation explained. Sorry. Yep. Let me fix that. Okay, can be explained. Okay, and then you're done writing this or interpreting this in terms of the context. And then for H and I, you're just you're calculating the residuals for 2 different year-old or month-old babies. Okay. So you're just using your equations. So you would do y equals 0.635 times 23 plus 64.928 see what height that baby is at that age. And then you do the same thing for I. 0.635 times 27 plus 64.928. Okay. So what are, wait, we had done that already, right? Yeah, we did for the stats. We did that already. Okay. So we're figuring out the residuals. So residual is actual minus predicted. Okay. So R equals A minus P. So this would be, what's the actual height of a 23-month-old child? So 79.7 minus the predicted amount that we figured out in our chart. So 79.533. Okay. Which one? We figured them out here. We already did it up here. These are the actual heights. So for a 23, I'm sorry, yeah. And then we have to do it again for 27. Okay. So these are the actual heights. So this, for a 23-month-old kid, it would be 79.7 minus our predicted amount, which is 79.533. Okay, so we got the residual is equal to 0.167, which is very close. Okay, it's almost exact to what we were able to figure out. And then for a 27-month-old kid, this would be 81.8 minus 82.072. So we got negative 0.2724. Okay. So I'd say for both of these, our model was pretty close in predicting the heights of those two kids' height at that age. Okay. Now if you got like a residual of like 2, 3, then you're off by a few inches, right, or centimeters in this case. So that covers the kind of the second part of the notes, kind of showing you how. Oh wait, we forgot one part, right? The standard deviation for letter C. No, it wasn't. It's a different. You have to go somewhere different. Okay. Yeah, for D. Okay, so go to stat, test. This is how to get the standard deviation for this data. Skip to the bottom, and you're gonna choose lin reg. Oh, not t interval. Lin reg t test. Okay. So stat test. Go to the bottom. Letter F. Keep all of this the same. Don't change anything. Just go down to calc. Hit enter. Okay, and then you're going to see this S equals. That's your standard deviation for this problem. So 0.256. Okay. So S is equal to 0.256. This is the alternative, so I don't have to give you another equation to find this out. And then you're going to interpret this in context of the problem. Okay. So y'all know what I think y'all know what a standard deviation is, right? It's how far your data varies from the actual average. So it shouldn't vary too much. So that's your standard deviation, and it's pretty much it. I mean, it was a recap of what we did yesterday. The only twist was I showed you how to sketch a residual plot. So make sure you write those steps down. You don't forget how to do that.